Hello everyone, welcome back to my channel. My name is Chinmay Shetty from the Sri Venkateswara College of Engineering. In this video, I am going to tell about analysis of covariance. Analysis of covariance is a technique used to compare groups while controlling for continuous covariate. Analysis of covariance is also known as ANOVA, allows researchers to examine the effect of an independent variable on a dependent variable while accounting for the influence of a covariate. The goal of ANOVA is to determine if the group or differences in the dependent variable are statistically significant after adjusting for the covariate. When to use ANOVA? ANOVA is useful when there is a continuous covariate that may affect the dependent variable. It is commonly used to research designs where randomization is not possible or when pre-existing groups need to compare. ANOVA is also used to increase statistical power by reducing the error variance associated with the covariate. Assumptions of ANOVA. ANOVA assumes that the relation between the covariate and the dependent variable is linear. The covariate should be measured without error and should be independent of the treatment groups. ANOVA also assumes homogeneity of regression slopes, meaning that the covariate has same effect on the dependent variable across the treatment groups. Steps in ANOVA. The first step is specify the research question and hypothesis. Second step is collect data on the dependent variable, independent variable and covariate. And the third step is conduct a preliminary analysis to assess the assumptions of ANOVA. Model assumptions. ANOVA assumes that the residuals are normally distributed. The residuals should also have constant variance. There should be no significant outliers or influential data points. ANOVA model equation. The ANOVA model equation can be written as y is equal to beta 0 plus beta 1 into beta 1 x1 plus beta 2 x2 plus e. Y represents the dependent variable, beta 0 is the intercept, x1 is the independent variable, x2 is the covariate, and e is the error term. The coefficients beta 1 and beta 2 represent the effect of the independent variable and the covariate on the dependent variable respectively. Main effects of ANOVA. ANOVA allows for the examination of main effects of the independent variable and the covariate. The independent variable represents the difference between the treatment groups on the dependent variable after adjusting for the covariate. The main effect of the covariate represents the relationship between the covariate and the dependent variable after controlling for the independent variable. Interaction effects. An interaction effect occurs when the relationship between the independent variable and the dependent variable differs across levels of the covariate. The presence of an interaction effect suggests that the effect of the independent variable on the dependent variable is moderated by the covariate. Significance testing. In ANOVA, significance testing is performed using analysis of covariance or analysis of variance also. The F test is used to determine if the group differences in the dependent variable are statistically significant after controlling for the covariate. The F value is compared to the critical value to determine if the null hypothesis should be rejected or not. Reporting ANOVA results. When reporting ANOVA results, including the F value, degrees of freedom, p value, and effect sizes, like partial, eta squared, or coincidences, can provide additional information about the magnitude of the effects. It is important to interrupt the results in the context of the research question and hypothesis. Advantages of ANOVA. ANOVA allows researchers to control for the effect of a covariate, increasing the precision of the estimates. It can reduce the error variance by accounting for the covariate, leading to increased statistical power. ANOVA is flexible and can be applied to various research designs, including experimental and non-experimental designs. Limitations of ANOVA. It assumes linearity between the covariate and the dependent variable, which may not always hold true. Violation of the assumptions such as non-normality or heteroscedasticity can affect the validity of the results. ANOVA cannot establish common misinterpretations. ANOVA results should not be interpreted as casual relationships, as it is an observational method. Failure to meet the assumptions of ANOVA can lead to invalid results and misinterpretations. Care should be taken to ensure that the covariate is truly a co-founding variable and not a mediator or moderator. Alternatives of ANOVA. If the assumptions of ANOVA are not met, alternative approaches like propensity score matching or structural equation modeling can be considered. If the covariate is categorical, logistic regression or analysis of covariance can be used instead of ANOVA. Researchers should select the most appropriate statistical method based on their research design and data characteristics. Conclusion. ANOVA is a powerful statistical technique for comparing groups while controlling for a continuous covariate. It allows to research examine the effect of an independent variable on a dependent variable while accounting for the influence of a covariate. Understanding the assumptions, steps, and interpretations of ANOVA results is crucial for conducting valid and meaningful analysis. Thank you.